Pre-feasibility analysis of energy efficiency measures for buildings and factories with RETScreen Expert. Part 2. Describing the facility. The previous video provided an overview of RETScreen's capabilities for pre-feasibility analysis of energy and fuel consumption in a building. I used RETScreen's archetype for a metal fabrication facility as an example. In this video, I'll continue with that archetype, but look in more depth at how facility characteristics are described in RETScreen. The Energy tab opens with the Include Measure table from the Summary section displayed. The navigation bar on the left-hand side of the Energy tab, mirrored in the menu bar, provides access to the various forms in the main screen that contain the facility description. I'll start at the top and work my way down. The Electricity and Fuels form provides the prices of fuels and electricity. Natural gas in cubic meters and electricity are included by default. In this archetype, they are assumed to cost 30 cents per cubic meter and 10 cents per kilowatt hour, respectively. Multiple fuels can be defined here. For example, I can add a second fuel by clicking on the plus sign. I see that the drop-down list provides many options, including natural gas, in units of gigajoules, therms, or thousands of cubic feet, as well as many forms of biomass. Only those energy carriers defined here are available for use within my analysis. For example, if I skip down to the space heating equipment for the office, I now find that I can select from among natural gas, electricity, and biomass for this heating system. Note, however, that there is no requirement to actually use the fuels and electricity made available in the electricity and fuels form. For example, nothing in this facility uses biomass, but there is no problem with me leaving this here. So don't be concerned that RETScreen automatically includes natural gas for a facility that only uses, say, electricity. Just ignore it if you don't need it. Clicking the drop-down arrow beside the heating value and fuel rate provides interesting information that allows for a better comparison of the energy content of fuels and how much fuels cost per unit of energy contained. I see that a kilogram of natural gas contains almost 3 times more energy than a kilogram of biomass, yet, at $30 per dry ton, the cost of biomass is only $5 per megawatt hour, much less than natural gas and electricity in this example. The Schedules form indicates how many hours per day a space is occupied, such that its requirements for interior temperature and ventilation can be defined for occupied and unoccupied periods. The schedules appear in columns. The desired interior temperature for space heating and cooling are given in the top 4 rows of the schedules table, first for occupied periods and then for unoccupied periods. The 24/7 schedule is included by default. This can be used when the desired interior temperature, or the ventilation requirement, does not change over the course of the day or the day of the week. Additional schedules can be added as needed by the plus sign button at the far right end of the form. Schedules can be deleted with the minus sign buttons at the bottom. This archetype has a lot of different schedules for different parts of the building. The schedule named Office Base Case that has been added by the archetype indicates that during occupied periods, the interior temperature of the spaces where this schedule is selected is 21 degrees Celsius during heating season and 22 degrees Celsius during cooling season. During unoccupied periods, these change to 19 and 24 degrees Celsius, respectively. Occupied periods total 9 hours per day, 5 days per week. If ventilation is only required when the building is occupied, this schedule could be used to specify those periods. The names that have been given allow the schedule to be identified in drop-down lists in other forms. For example, if I look at the Office Envelope form, I see across the top that the Office Base Case and Office Proposed Case schedules have been selected. I also find that these schedules have been used in the Ventilation form for the office space to indicate when ventilation and fresh air are required. The use of 2 different schedules for the Base and Proposed Case allows for the impacts of changes in thermostat settings to be investigated. Below the schedules, the heating-cooling changeover temperature has been specified as 15 degrees Celsius. RETScreen compares this threshold to the average outdoor air temperature to determine the length of the heating season and the cooling season. RETScreen assumes that when the average outdoor air temperature is above this threshold, no heating, beyond that supplied by internal gains and solar gains, is required. Conversely, when the average outdoor air temperature is below this threshold, no cooling is required. For this building, located in London, Ontario, these are 225 and 140 days per year. There are a number of approaches for choosing an appropriate heating-cooling changeover temperature. If the building exists already, you might ask the building manager. You should look at the length of the heating or cooling season to see that it corresponds to the fraction of a typical year when heating and cooling, respectively, are required. This works for buildings that require only heating or only cooling too. Simply ignore the season when the equipment is off. For buildings that have a shoulder season when heating and cooling are required simultaneously, or when neither is required, you may find that it is acceptable to attribute half of the shoulder season to the heating season and half to the cooling season. Finally, the heating-cooling changeover temperature can be adjusted when attempting to reconcile the energy page model with monitored data for the annual building fuel or energy consumption, as will be described in the fourth video in this series. If the building has not been constructed, however, it can be quite challenging to pick an appropriate value for the heating-cooling changeover temperature. You might consider other buildings, similar in age, construction, and use. Or you might start with a temperature around 16 to 17 degrees Celsius, and then adjust it downwards if internal or solar gains are particularly high, the envelope is well insulated, the infiltration is low, and fresh air ventilation requirements are not particularly high. One note of caution. The heating and cooling changeover temperature input appears below the column for the 24/7 schedule, but it is not directly related to this schedule. As mentioned earlier, it determines the length of the heating season and the cooling season, which is used in applying all schedules. The equipment section is for equipment that generates heating or cooling. Anything that needs heating or cooling appears in the next section, end use. So, the heating and cooling systems are defined under the equipment section, and then for each heating or cooling requirement in the end use section, the heating or cooling system can be selected from a drop-down list. For example, if I look at the heating system drop-down list for the office ventilation form, I find the heating systems that appear in the equipment section. The heating systems are defined solely by the fuel that they consume and their seasonal efficiency. That is, on average over the course of the year, how efficiently they convert the fuel energy into heat. There is a base case and a proposed case, which will be the same if plans do not call for a change in the heating system. In this situation, the incremental initial costs and O&M savings are obviously zero. Cooling systems are similarly described solely in terms of the fuel and the efficiency. For vapor compression cycle cooling systems, the fuel will typically be electricity. The efficiency is given in terms of a seasonal coefficient of performance, or COP, which relates the units of cooling produced for each unit of input fuel energy. In this archetype, the air conditioning system extracts 3.1 kilowatt hours of heat from the building for every 1 kilowatt hour of electricity it consumes. Within the heating or cooling system form, clicking on a checkbox accesses additional parameters related to equipment selection. The equipment capacity specified here may be helpful for costing, but does not figure in the energy calculation. The checkbox beside Refrigerant Optional opens a section that allows the refrigerant to be specified. Its impact in terms of cost and greenhouse gas emissions can then be calculated based on the fraction of the refrigerant charge that is lost each year. The End Use section includes equipment that requires heating or cooling, or that consumes electricity for some purpose other than heating or cooling. This can include a wide range of equipment, as seen in the menu ribbon drop-down list. A form that will be useful for many facilities is that describing the building envelope. If there are distinct spaces within the building, like the office and manufacturing spaces for this archetype, each may have its own envelope form. The interior temperature for the space is specified through the choice of schedule, which may be different in the base case and the proposed case, as shown here. Then the heating and cooling load before internal or solar heat gains is calculated based on infiltration of outside air, and on the insulative properties specified for the walls, doors, ceiling or roof, floor or slab, and windows. There are unit switches that convert between R values and U values in either US customary or metric units. If you are entering your own data, make sure that the switches are set to the appropriate units for your inputs. This is probably the most common cause of errors in a RETScreen building analysis. The solar heat gain coefficient indicates the fraction of incident sunshine that penetrates the windows and is transformed into heat within the building. If shading reduces the sunshine incident on the window, the percent reduction should be specified for winter and summer under the solar shading season of use. The resultant solar gain is applied to the heating or cooling load for the form in which the windows appear. The window U values and solar heat gain coefficients can be entered directly into the envelope form, as shown here, or they can be linked to a window properties tool through the icon in the envelope form. The Windows Properties tool, which can also be opened independently from the building envelope form by clicking on the icon in the Options section of the menu ribbon, is useful in three ways: as a database of Windows properties, as a way of adjusting the Windows properties to account for the size of the windows, and as a way to aggregate all the windows in each wall direction. Walls and roofs also benefit from a tool for finding the R value based on the materials used in the construction. The form appears in italics in the navigation pane. Its finding for the effective R value can be linked to the corresponding input cell in the building envelope form. In this case, a chain link icon appears in the cell. The building envelope form has a section for floor and for floor below grade. Note that the former is used if the floor is exposed to the air, the latter when the floor is an on-grade or below-grade slab. Once the characteristics of the envelope have been specified, RETScreen is able to calculate the heating and cooling requirements for the space. This appears at the very bottom of the form. The results are given in kilowatt hours, but do not assume that this is an electric load, or indeed any measure of fuel consumption. Rather, they are the thermal energy requirements. The heating and cooling systems that are used to meet these requirements are selected from the drop-down lists at the bottom of the form. The ventilation requirements for the space are specified in the ventilation form. This office space requires 1200 liters per second of ventilation air, but the percentage of this that is fresh will be reduced from 75% in the base case to 60% in the proposed case. With the fan control set to schedule rather than constant, RETScreen will assume that the ventilation fans operate only during the occupied hours specified in the office base case and office proposed case schedules. If the fan control is set to constant but the ventilation control to schedule, then the fresh air damper will be open only during the occupied hours specified in the schedule. The selected schedule also dictates the temperature at which the ventilation air must be supplied. The electricity consumed by the ventilation fan motor does not figure on the ventilation form. The note that this ventilation form is linked to fan's office tells me that the equipment described here is intimately related to the equipment described in the fan's office form. That page describes the motor and fan and estimates their electricity consumption. If I make changes to the ventilation form, such as selecting a schedule with a greater or lesser number of occupied hours per week, I should ensure that I make any necessary changes to the corresponding fans form. As in the building envelope form, the heating and cooling required to supply ventilation air at the desired interior temperature are indicated at the bottom of the ventilation form. Note that RETScreen does not calculate the latent heating or cooling load, that is, the energy required to add or remove humidity from the air. This is an important consideration for both ventilation and infiltration, particularly in extremely humid or dry climates. A lighting form is a bit different because it does not require a heating or cooling system to be selected. Rather, RETScreen calculates the electricity consumed by the lights. Obviously, this electricity is eventually transformed into heat. The user can indicate to what extent this heat reduces the heating load, increases the cooling load, or does both. For example, 40% of the heat from the lights described in the office lights form is subtracted from the heating requirement during the heating season and added to the cooling requirements during the cooling season. The user cannot control how RETScreen apportions this heat among the different building envelope and ventilation forms. For exterior lighting, it makes sense to set the space heating and cooling impact to 0. In an industrial plant such as this, there is a lot of machinery that consumes electricity. The office equipment and IT equipment are presented in the electrical equipment section. A selection of the industrial equipment is described in the process electricity section. An air compressor is a special class of industrial machinery, and it is included in its own section, where the electric load is estimated based on the pressure and air demand. Fans and their motors also have their own section. For each of these electric loads, the percentage of the electricity consumption that is assumed to result in heat that is added to the cooling load during the cooling season and subtracted from the heating load during the heating season is specified. The end-use forms will generate requirements for heating, cooling, and electricity. Solar, wind, or other green power technologies can satisfy all or a portion of these requirements in the proposed case and are defined under the optimized supply part of the form. In this archetype, solar water heating reduces the heating requirement, and a 236 kilowatt photovoltaic system reduces the electricity requirement. RETScreen does not determine whether the times when there is solar generation correspond to the times when there is a requirement for heating and electricity. Thus, it ignores the possibility of generation that must be wasted or sold to the electric grid because it is in excess of the concurrent load. Opening the solar water heater form, I see that the very top input cell is a drop-down list referencing hot water loads. In this archetype, there is only one, and this is what the solar water heater will be used for. It is described on the hot water form. In the proposed case, the office space needs 340 liters per day of water at a temperature of 55 degrees Celsius. 6,902 kilowatt hours of heat must be provided, and if the heat from the solar system is not sufficient, this will be supplied by the domestic hot water heating system. Returning to the solar water heater form, I see that with around 9 square meters of glazed, flat plate collectors and 600 liters of storage, almost 60% of the proposed case water heating requirement can be met by solar water heating. That is an overview of this archetype's description of the facility. In the next video, I will show how to view and interpret RETScreen's results for the energy and fuel consumption.